First, I will thank you all for having accepted our invitation to be here for this presentation. I also take to thank the INA and CREAD and myself included for having organized this interesting conference. So my presentation will be about the limits of parametric reforms in maintaining the financial sustainability of the Algerian retirement system for the long run. So I will start, that's the plan of my talk. I will start by talking a little bit about the motivation which pushed me to do this work. I will also present a general overview of the Algerian retirement system. How does it work? How the financial balance is maintained? And then I will, in the beginning, I will start by presenting one scenario case. Then I will move to the multi-scenario analysis, and at the end I will present you simulator, an online simulator that I have developed in order to play with the different scenarios about the evolution of the environment and also the possible reforms action that can be taken by the CNR. So the debate about the sustainability of the Algerian retirement system and the needs for reform started at around 2015 or 2016. Everybody start to talk about the need for reforms and how this reforms need to be done, but there have not been a lot of works who analyze this, how this reform should be done. So in the beginning, we published this paper in 2020 in a book edited by Pierre de Volder, Immaculada Dominguez Fabian, and two other professors from the University of Extremadura in Spain. It was about the economic challenges of pension systems, and it gathers different experiences from different countries in the world: Spain, France, Italy, and Japan, and also the Mexican case. And of course, there was a chapter dealing with the Algerian case entitled Financial Sustainability of the Algerian Retirement System, or Perspective Analysis of the 50 coming years. So a part of this talk will be based on this paper. So I will start by presenting how the retirement system or retirement works. So if we take this diagonal line as the life course of a normal individual belonging to the global population. So in the pink is infanthood and childhood. In age 15 we enter into the labor market, and the blue part is represent the working career of an individual, and the gray is correspond to the retirement age. So during the first phase, or the contribution phase, all workers pay a part of their salary as a contribution for social security, and this includes a part for retirement. So the contribution rate for social security is estimated at 34.5%, which include 18.75 as contribution for retirement. At retirement age, at the age of departure of getting retired, which is set actually at 60 or 65, depending on the type of job that you are doing, and many other parameters decide about the age of retirement. Right now, we estimate the first pension benefits, which is based on the final wage. Here is considered as the average wage of the last 5 years of the working career, by 2.5, which represent the annuitization rate. So for each year of contribution, we provide the worker with 2.5. That's will allow the worker to accumulate 80% of replacement rate, corresponding to 32 years of contribution. All this is will allow us to estimate the first pension benefits, and each year this pension benefits is upgraded by, usually it's 5%, but sometimes it's set at 2.5% to 3%, depending on the economical situation and inflation evolution. So then, and after the death of the main retiree, there are survival benefits which are paid for the surviving widow or the surviving children or parents. So now let's see the same issue from the retirement provider or the retirement fund point of view. So for what matters for retirement fund is this balance between the total of retirement incomes and total retirement outcomes for each year of the observation period. And this equilibrium is very related to the size of the two populations. From one side we have the population of contributors, and from the other side we have the population of retirees. And to maintain the financial balance equilibrium, we need to have the total for each year from the projection horizon. We need to have the total retirement expenses equal to the total contribution paid by the affiliated workers. And here we see why this relationship is actually threatened by the population aging of the Algerian population. So we have the population of elderly at old age is growing faster than the population at working age, and that's the result of some projections that we have done at CREAD. In the first plot in the top left, we see the expected evolution of life expectancy for males and females. In the top right, we see the evolution of the total fertility rate. We were at more than 7 children per woman in 1966, and we went through a transition cycle which brought the fertility rate to 3 children per woman actually. And this is the expected evolution chance which that the population pyramid will undergo from now to 2017. In the middle is the global population evolution, and the most interesting part in this graphics is the plot down to the left, which represents the ratio of the population at working age corresponding to 1 people at retirement. In 1966, we had around 6 to 7% at working age, corresponding to 1 person at age older than 60 years. So now this ratio is expected to fall for the first time in the history of the independent Algeria below 6 in 2021. And this ratio is expected to fall, continue its decrease, and to reach 2.7 by the year 2040. And we can easily imagine the effect that this aging process might have on the financial sustainability of the Algerian retirement system, so which start to face some problems with the financial sustainability with the ratio of 6 or of 7. So what will be the situation when this ratio will be at 2.5 or less? Of course, this ratio doesn't represent the ratio of real contributors to real retirees, but it will help us to have an indication about the future evolution of demographic parameters. And that's the result. We can easily observe the evolution of the financial balance of the CNR, and the most important question is what's the upcoming of this issue. And here some change needs. are needed. You remember all this simple substitution made by the Algerian trainer in the second half of the game, which between Algeria and Tunisia in the final of the Arab Cup. And that's the most important decision taken by the trainer of the national team. That's the player which scored the winning goal for Algeria in this final. So taking the same thinking process and we apply it to a retirement system. So here the change is needed. An adequate change or reform is needed. So, but before to allow this decision to be adequate and to the current situation, we need first to assess the financial sustainability of the Algerian retirement system. In order, when we talk about the financial balance, we have from one side we have to project retirement incomes from one side and retirement expenses from the other side. So for incomes, we have to estimate the population of contributors, which is defined by the population growth, activity and employment rates, the salaried employment rates, which means the part of salaried workers in global total employment, and also we need to have data about the affiliation of social salaried workers to return. All this, the first part needs to be multiplied by the average yearly contribution for retirement, which is defined by the average wage, the contribution rate for retirement, and also the collection factor, the taux de recouvrement. The blue and the green tell us about the scenario that we're adopting about the future evolution of that parameter. Green corresponds that for the variable market with green, we assume a constant evolution, that the past observed evolution will be kept in the future. While for the blue or the variables marked with the blue, we keep using the same recent observed levels. On the other part, we have outcomes, which are defined by the population of retiree. This last is defined by the population growth and the age of retirement, and also the average yearly pension benefits, which is calculated based on the duration of contribution and monetization rate, which is set at 2.5 actually, the final wage and the pension annual revaluation rate, for which we add survivor pension expenses and administration fees, which are assumed to be, were considered to be a fixed part of retirement outcomes or expenses. So, starting by the first part, estimating the incomes. So incomes, total contribution for year T is represented by the sum of the contribution paid by all the individuals aged X at time T. Ages goes from 50, but in reality we consider the age of 18 as the first age of entering into the labor market, and it goes till 64. So LX is the global population, ASX is the affiliation rate for Social Security at age X, WT is the final wage, and 18.75 represent the contribution rate or the share of the wage paid for retirement. So on the other side, we developed a simplified methodology to allow us estimating the evolution of future retirement expenses. So because it's very difficult to estimate exactly how many retirees we will have in the future, especially if we start from missing data. So simply we assume that all people reaching the retirement age are assumed to be potential retirees, of course with specific average expected duration of contribution and final wage. So to do this, we need to retract the history of contribution of each cohort of people. For example, if we take an individual aged 100 years in 2020, so it should have started his working at the age of 18, which corresponds to 1938. I will explain further details about this point in the next slide. And the concept of the expected duration of contribution was first introduced by Costa in 1998, and myself and Blanche in 2020 we developed and we adjust this concept to another case. Also, we assume that the survivor benefits expenses to represent fixed part evaluated at 20% of the total direct pension expenses, and administration fees to represent 1.5% from the total retirement expenses. So that's a simplified scheme of the methodology that we have already represented. So the first two squares represent population at working age that we need to multiply by the probability to contribute for retirement. Each rectangle represents a matrix which have the ages in line and the years in the column. So when I say population at working age, it's the matrix representing the evolution of the Algerian population from the first year to now, and for ages from 18 to 65. And the same, all matrices have the same dimension. The same for the matrix representing the probability to contribute for retirement, the annual average salary, and also the rate of contribution for retirement. We multiply all by the correction factor to obtain the total contribution. Same from the other part, the other side, since all the population at retirement age are assumed to be potential retirees, for which we adjust the expected duration of contribution and the final wage, and so on. So we estimate the direct pension expenses, and we add the survivor pension expenses and administration fees. So the difference between the two parts of the equation is meant to be the financial line. So let's start with a short overview about the situation of labor market in Algeria and affiliation to Social Security. So starting from the down, so we have here, for example, we have from all the people at working age, 42% are active. 37 from the total, 37 are employed. 29% are salaried workers. Others are either independent or or employers. And only 70% are affiliated to Social Security. So among 100%, only 17 persons contribute for Social Security. And on the other side of the graph, we observe the expected or the probability to contribute for retirement by age for males and females. And we observe the huge gap between males and females, which is mainly due to differences in activity rates, because activity rates for men are estimated at more than 80%, while the activity rates for women are only 18 or 17%. And based on this distribution of the probabilities to contribute for retirement, we estimate the expected duration of contribution. Here, for example, for the year 2020, each man from the global population is assumed to contribute during 15 years during his working career, while for women, the expected duration of contribution in 2020 is only 4 years. And these values are used to estimate the average first pension benefits for the global population. That's why I say that this calculation is based on the average expected duration of contribution. So that's the data issues that we have faced in preparing this work. So first we have the shortness of the observation history. So to do such work, we need to go back to 1938, which is theoretically, practically impossible. Science data is missing for the period before 1962. So what we propose to do is just to retropolate the trends observed beyond 1962 to the period before. We remain in the theoretical framework, waiting for better condition in regards to data. So the second problem that we have faced is that data is not always age detailed. So we have either global or summary indicators like global affiliation rate or global employment rate, and we have not always the age distribution of this rate. So what we propose is, we propose in this paper two components methods which is more likely to be applied on the context of mortality modeling, which aims at assuming two vectors, one representing a time trend, like the global rates, global employment rates, and global affiliation rate to social security, and age pattern. The age pattern is estimated on as the ratio of the rates corresponding to the different ages on the global rate. If we take, for example, the employment rate, we take the employment rates at different ages and we divide them on the global employment rate for this year. Also, as third points, we have data is not always disaggregated by sex. So we, based on some data, we estimate a relationship or a model, a relational model, allowing to estimate male and female values starting for the global ones. And that's the application of this method on the surface of the wages evolution. Here we see the evolution of the average crude wage for Algeria from 1966 to now, and we observe easily that the wages have evolved with the rate of 8% from 1990 to now. But if we consider only recent years, the average evolution rate is only 5%. Here's here in the second plot, the age pattern estimated based on the ONS survey taken in 2011 in concern of the household revenues. So this combination of these two parameters will allow us to estimate the surface of wages for meals. Here we see the ages, the years in below, and the evolution of salary. And we observe that the salaries of women are slightly higher than those of men. We have done the same thing for employment rate. That's the employment surface for males and the employment rates for females. Same for the part of salaried workers in total employment. We used exactly the same method for all parameters. And in final, that's the surface of age-specific probability to contribute for C and R. This two type of graphs represent the same indicator. The only definition is that here is the 3D presentation and this one is 2D presentation. I will now show you how to read this kind of presentation. So, for example, if we take this point will correspond to the year 1990 and the age of 42. And the level or the probability to contribute for C and for an individual from the global population is around 45%, and so on. So the color scale allow us to read the differences between individuals' ages or years in regard to the probability to contribute for retirement. Now, how to use all this? So we use the population projections and the probability to contribute for retirement to estimate the part of the population of contributors. And we multiply them by the age surface, and that allows us to estimate the total contribution paid for Social Security or retirement. Same for the outcomes. And here's how to read the data. For example, if we need to estimate the expected duration of contribution for any individual which started working at the year 1960 and get retired at the age of 65 in 2005. So we need to sum up all the probabilities of contribution in this line. And here, for example, for the case of Algeria, the expected duration of contribution for an individual getting retired at the age of 65 is 16.84. For someone who is getting retired at the age of 60 is 16.2, and so on. And this value is estimated to estimate the first pension payment. And that's the final result. The total outcomes and the total incomes, and we observe here the deficit or the future deficit of the CNR in future years. And now, after this presentation, someone, for example, can say that if we do this, if we change some parameters like the age of retirement or the contribution rate and so on, we maybe need to can save the financial sustainability of the Algerian system. So that's in the second step, we decided to go to multi-scenario analysis. We distinguish between two types of variables. We have environment variables like population. For population change, we used 15 scenarios, crossing 5 scenarios of fertility evolution. Fertility rates for the year 2050 are said to be at the level of 1.5, 2.1, 2.5, 3, and 3.5. That's the 5 scenarios of fertility crossed with 3 scenarios of mortality evolution. And we used also 3 employment scenarios. Otherwise, the first scenario is represent the current level, and the scenario up and the scenario down. The same for salaried employment rates, affiliation to Social Security, wage evolution rate. The summarized scenario is 5%, the up is, or the down is 8, the up is 2%, and collection factor, we use 3 collection factors, 80%, 70%, and 99%. For the system variables or the parameters that CNR or policymakers can play with are the age of retirement, the period used to estimate the reference rate, which is actually 5 years. The contribution rate, we compare 3 parameters, 3 values. Amortization rate, also 3 values, and annual revaluation rate, 3 values. And in total, we got nearly 1 million scenario, with including 243 possible combination of actions, and the estimation of the model of all the parameters takes around 80 hours. That means 4 hours running time, and this may include when the process fails and we need to restart the process again. And that's the population projection we have used. The data and are available on my web page. I will show you later how to access to this web page. And this is the expected evolution of the ratio of the population at working age to the population at retirement age. The green line represents the result obtained with retirement age set at 65 years, while the red lines represent the case when age of retirement is said to be 60 years. And that's just the result obtained with some scenarios. That's in the dark line represent the average scenario, and the others represent the result obtained with all the other scenario. And here it's line 0. It's the line of we have no benefits, but we have no deficit also. So as we observe here, the cases where we can expect to have a positive financial balance of the C and R is really few. We have only few cases, and this positive level cannot be maintained beyond the year of 2014. So, and that's some results. And we can easily, as a conclusion, I can just say that some parametric reforms can be useful to maintain the financial sustainability of the Algerian system, but only to 2014. So for now, we can maybe plan to make some parametric reforms just to save time and to save the situation until 2014. But beyond 2014, we need to make some, I cannot say more serious reforms, but structural reforms. And thank you.